Okay, so we're going to backtrack a bit now, and we're going to have a notation. So we could talk about this in some way. So what we're going to say is we're going to have now you may have seen this before in domain and range if you ever did something like that, but if you didn't, it doesn't matter. What this means is this is the probability of B given that the probability of B given that A has occurred. So the way we say it is we say the probability of B given A. So we want the probability of B given that A has already happened. Right. So, for example, let's say we had a Venn diagram. Say this is A, this is B, and we'll say that there is a 30% chance of being in here and a 20% chance of being in here, 45 there, 5% of being in there. So if I said, what's the probability of A, what's the probability of B, what's the probability of A and B, and the probability of B given A. Okay, so let's fill some stuff in. So the probability of A is 50%, which is 0.5. The probability of B is 65%. The probability of A and B, looking at the diagram, so I'm not doing any calculations, is 0.2. Now the probability of B given A, so if I'm doing B given A has occurred. So imagine there's 100 people, 50 of them would, here's the area where A has occurred. So there's only 50 of them left. And the probability of B happening, so this area over here, this is the area with an A that's also a B. So it's going to be 20% over the 30% plus 20%. It's going to be the B part over the whole A part, which is going to be 0.2 on 0.5, which is 40%. So the probability of B, given that A has happened, is 40%. And it could also be the other way. It could be the probability of A given B. So now we're given B, so we're in there, and that would be the 20% on the 65%, which would be 30.77%. So we're going to make another point about this is that, so if we look at this formula over here, we could see that the probability of B given A was the 20%, which was the probability of A and B, over that's the 30 plus the 20, which is just the probability of A, over the probability of A. Or, if we rearrange it, we would say that, so actually we have a formula So the probability of A and B, if they're dependent, is going to be, if we move that up to there, the probability of A times the probability of B given A. Or the other formula is the one that we already had. The probability of B given A is the probability of A and B over the probability of A. And those are the two formulas. Now, we could have also done it for the other way around. We could have said the probability of A given B was the probability of A and B over the probability of B. So that's the one that goes on the bottom. So given A, given B, and there's our formula.